Okay, so first we'll be talking about light sources. So we can divide light sources for spectrometers into two broad types, the two main types. So first we'll discuss what are known as broadband lamps. Broadband lamps means these are light sources that produce light across a wide range of wavelengths. And then our second type of source is a monochromatic source, something that produces a specific color of light. And there are kind of two main classes of that. There's lasers, which we'll talk about, and then hollow cathode lamps, which are used for atomic spectroscopy. We won't actually talk about that in this chapter. We would discuss in chapter 21 if we were getting to that. But I just want to, for completeness sake, include it on our list here. So most spectrometers, and I think probably all the ones that you've used for our class, use these broadband lamps, these broadband light sources. So these are very useful because they emit a bunch of different colors of light, and then we can use a monochromator to select the specific color we need for our application. And so these are really good for general purpose spectrometers where you want to be able to measure a wide different range of molecules that could absorb light at many different possible wavelengths, or emit light at many different possible wavelengths if you're using, say, fluorescence. And so the type of lamp you use depends on the wavelength range that you need. So kind of the three main wavelength ranges we'll consider are ultraviolet, UV, visible light, and then infrared light. So for ultraviolet light, the most common lamp source is a deuterium arc lamp. And so I have a picture of it here that I found on Wikipedia. And so this is it right here. And so the idea here is we have deuterium gas that's present in this lamp, and we arc a discharge through it, so an electrical discharge, and that excites the deuterium molecules to an excited state, and then as they relax to the ground state, the particulars of deuterium means that they emit light not at just a single wavelength, but throughout the ultraviolet region. And we won't go into why that is specifically, but that's the idea. And so this provides UV light across a wide range of wavelengths, and then we can use the monochromator to select the specific wavelengths we want. For visible light, some of the most common ones are tungsten filament lamps. So this is basically an incandescent bulb that you're probably familiar with from light bulbs in your house. Though they're becoming much less common than they used to be because they're pretty energy inefficient. So they've been replaced by fluorescent lights, or more recently, light-emitting diodes. But anyway, the idea here is that we have a small tungsten filament, which is right here, and we heat this up using electricity to something like 3,000 Kelvin. The reason we use tungsten is it has a very high melting point. So we can heat it up really to pretty high temperatures before it starts melting and you can't use it anymore. And so the hotter we get it, the more the light shifts into the visible. And so we heat it to about 3,000 Kelvin with electricity. And usually inside of this bulb, we have some sort of inert gas so that it doesn't react. We have to exclude oxygen, or else we'll oxidize our tungsten when it heats up, and then it'll stop working. So our bulbs usually contain argon or something like that, or possibly nitrogen. The important thing is that it doesn't contain oxygen. Mercury or xenon arc lamps are another possibility. They look something. This is a xenon arc lamp. So these are kind of a similar idea to the deuterium lamp. We spark an electrical discharge through either mercury vapor or xenon vapor. The mercury vapor, that's what's inside fluorescent light bulbs, and so this is something that's used, again, in common lighting for our houses. And another thing that's starting to become more common are LEDs. Just like they are in our residential lighting and things like that, LEDs are becoming more common also as light sources in spectrophotometers. So they have a lot of advantages in terms of energy efficiency, as well as cost and longevity. So LEDs last for a lot longer than these other types of lamps, so you need to replace them much less often. So there's but you know, the technology is still progressing in terms of getting the right range of wavelengths that you need for a spectrophotometer. So with these two types of lamps, what's often done in a UV vis spectrophotometer is that we'll have, move me out of the way here, we'll have one of each of these types of lamps in a spectrometer so that we can cover both the ultraviolet and the visible range. For example, this is a figure from your textbook down here in the bottom left. A deuterium lamp will typically cover something like 200 to 400 nanometers. And then a tungsten lamp, like a tungsten filament lamp, will cover sort of the rest of the range down to about 1,000 nanometers. And so that lets us cover both the UV and the visible range. And then in software, as we run the instrument, it'll switch between these two depending on what wavelength we ask for. Okay, so one other wavelength range we need broadband sources for are infrared. And so the most common thing here is to use something similar to a tungsten filament lamp, just not as hot. So the kind of the industry standard is what's called a glow bar. It's made out of silicon carbide. And this is basically like the heating elements you have on an electric stove. So you heat it up and it glows very bright in the infrared, and then you can use that light. Again, we'll talk about for infrared, it's typically not a monochromator that's used, but we'll discuss how we differentiate the different wavelengths of light instead. But here's a picture of some different glow bar sources. So the actual glow bar is this little part right here. And the rest of this is just the electrical connections to heat this with electricity.